Did you know that there's one area of mathematics into which you can become as expert as anyone? And that would be in graphing. So those of you who end up in calculus will learn all the techniques of graphing functions that are known. So anyway, it's something to look forward to, I'm sure. Well, we start simple in this course, graphing just lines. Now near the end of the course, we'll graph something else called exponential functions. But for the moment, let's focus on lines. So my first example is to graph 3x minus 5y equals to minus 15. All right, well, this is called a linear equation. I think I discussed this in an earlier video, but as a linear equation, the variables have powers of 1. Nothing else. There's no x's in denominators, there's no square roots, or any kind of funny business like that. Nothing is squared or cubed. Just first powers. All right. And the word linear is well chosen because these graph as lines, as we'll see. All right. Well, there are, as far as graphing lines, there are two major techniques. And the first one I'm going to show you is plotting points. The second one, which we'll explore later, is using the slope and the y-intercept. So anyway, to plot points, I need a chart, and I pick either an x value or a y value. That's the idea. And then we plug it in and calculate the corresponding other value. So for example, if I let x equal to 0, then my equation becomes 3 times 0 minus 5 times y equals to negative 15. And this would give me 0 minus 5y equals minus 15. So the 0 is just going to cancel, basically. Divide by negative 5, and the negatives cancel. All that stuff cancels. Y equals to 3. All right, so important here. It is a function relationship, as it turns out. These equations, where there's two variables in it, is always a relationship between the two variables. There's a relationship which we're attempting to see is what describes that relationship. And so, in other words, when x is a certain number, then there's a corresponding y value that matches up with that x value. And there it is, 0, 3. All right, let's do another one. Let's plug in, for example, 0 for y. You notice that I like to use 0 because 0 is so easy to calculate with. And so if I plug in 0 for y, I get 3x minus 5 times 0 equals minus 15. Again, that's going to cancel because it's 0, so I have 3x equals to negative 15. Divide by 3, and we get negative 5. So when y is 0, x is negative 5. Well, we can list some more points. For example, if x was 2, what would y be? So let's go after that and see what we get. So 3 times 2 minus 5y equals minus 15. That would be 6 minus 5y equals minus 15. If I subtract 6 from both sides, I get minus 5y equals minus 21. And now divide by negative 5, and I get 21 fifths. 21 fifths is 4 1/5, or precisely 4.2. All right. Well, there's nothing wrong with fractions on graphs. You just have to estimate where they go on the grid. Now, if you end up with nothing but fractions, you might want to adjust your scale to accommodate fractions. In other words, you might use a scale that is fractions. But normally we try to avoid fractions when we can. So, but it turns out, if this is a straight line, how many points do you need to graph with? It only takes 2 points to make a unique straight line. That's an axiom from ancient Greece geometry by Euclid. 2 points to find a unique line. So I really don't need this third point. Now, textbooks will tell you to do 3 points, and the third one is to check yourself. To me, that's up to you. If you're confident of your work, then take your chances. Fine with me. I'll just see if you're right or not. Okay, so anyway, most people do a very good job of graphing, particularly the people that practice. All right, well, this point is 0, 3. And 0, 3 means 0 on the x-axis and 3 on the y-axis. So it's about here. And this point is -5, 0. So that's -5 on the x-axis and 0 on the y-axis means it stays right here. So it turns out these are called intercepts. And in fact, when you use zeros like I did, that's called the intercept method of graphing. And it's nice. I like to do it because you can practically do it mentally. If x is 0, solve for y. Y equals to 3. If y is 0, solve for x. Divide by 3. X is -5. Very quick to do. You'll see a lot of equations like this in one chapter of our finite math course if you end up taking finite math. And so people get really fast at graphing these. All right, the line itself would connect the dots. So there we go. And what about this one? 2 and 4 1/5. Well, if x is 2, 4 1/5 would be above 3. That looks right. That looks like it's correct. All right, now I'm happy with this graph. I think most people like to fill in some spaces, which is perfectly fine. I don't gripe at all. Oops, I didn't count that right, did I? Let me try that again. Okay, 1, 2, 3, 4, 5. There we go. And here, I'm going to kind of hammer you about this in your homework and test. And in these videos and in my book, that you need to put some numbers on your graph on each axis so we know what the scale is. All right. Without these numbers here, how do we know what the scale is? Is it in tens? Is it in hundreds? What is it? We don't know. So I'm going to expect you to put numbers, at least one number on each axis, so the reader can tell what scale it is. I'm going to expect you to draw the line from end to end. Fill up the graph. Don't just draw a little piece of it. I'm going to expect that the scale markings on each axis are evenly spaced. They don't have to be the same spacing for each axis, but as long as they're evenly spaced, I'm fine. And I'm also going to expect large graphs. So when you give work to me, if you're my student, I want graphs that are about this big, at least. All right. If you want to make it bigger, that's okay. But I've got trifocals. My eyes are getting old, and when you draw little tiny graphs, like are in the back of your textbooks, little tiny graphs, it's hard to see detail, and so to me that's I count off for that. So give me a decent sized graph. All right, I will talk about that in yet another video. Anyway, that's the idea. And there's our line. So I'm going to erase this and show you another line.